When Neil deGrasse Tyson made his unexpected revelation about Neptune, it not only had a strong impact on the astronomical community, it also shook the foundations of what was until now considered a well-understood corner of our solar system. Tyson, known for his ability to explain complex astrophysical phenomena, spoke to a packed auditorium during a recent symposium broadcast live worldwide. The entire world watched in awe as he presented findings suggesting that Neptune, the icy giant that dwells at the edge of our planetary family, may not be what we always believed it to be. Before we begin, we invite you to like the video and subscribe for more updates. For decades, Neptune was listed as the 8th planet from the Sun, a cold blue sphere of gas and orbited the reach of the Sun's heat. It was discovered in not by direct observation, but thanks to mathematical calculations made from irregularities in Uranus's orbit. Our knowledge of Neptune has been based mainly on sporadic telescopic data and a single visit by the Voyager. That brief mission provided limited images and data, showing a frozen and dynamic world with supersonic winds, massive storms, and a deep blue color. However, much of Neptune remained. Tyson's revelation changed that of recent observations, being a combination of data from the James Webb Space Telescope and insights from Earth. These observations revealed an internal composition and behavior that do not match our current models of gas and ice planets. According to Tyson, detected completely challenges the conventional understanding of its internal structure and how it generates its magnetic field. Instruments detected strange patterns in the planet's gravitational field, in its electromagnetic emissions, and even in its heat output, suggesting a much more complex and volatile interior than anyone had described was a Neptune, with not simply organized by density or temperature, but altered by dynamic movements that seem to dynamic expectations for a planet that's from the Sun. Instead of a uniformly differentiated ammonia and an outer gaseous envelope, is to have a mosaic interactive zones with intermittent plasma-like materials and unexplained warms of the clouds. These should not exist of traditional models, solar at distance to generate them, and there are no signs of tunes with sufficient mass. Something internal and expected. Even more revelation about Neptune's magnetic field. It was already usually tilted and offset from its center, but recent data show that the field is not only skewed, but also varies erratically over time. Its structure is to be in constant flux, with shifting in cycles that had not before led to the hypothesis that Neptune's the mecha generates its magnetic field may be nothing like that of other planets. Instead of a convective metallic or a layer of conductive hydrogen, Neptune could have a layer of exotic ice undergoing chemical transfers under pressures, which generate charge flows responsible for this changing magnetic field. Tyson even raised a possibility among the scientific community that these anomalies could indicate that Neptune is or contains pockets that ask for electromagnetic and gravitational energy. Although still speculative, it is being increasingly discussed and could revolutionize planetary science. A planet with such an internal architecture would behave very differently from the solid or gradually most models. The implications are profound. If Neptune is so different we believed, that forces us to re-evaluate the history of the inner system. Neptune, according to current, migrated from after its gravitational interaction orbits of other planets and possibly connected to the inner system, and turns out to be a more exotic entity. The history of our solar system's evolution is more complex and dynamic than described. Another to the detection of the radiosphere. Its radio waves between its magnetic field and wind have frequencies that do not what has been observed previously. Some researchers are possibly related to quantum behavior within the sphere of the planet, or natural phenomena that we do not yet understand. Extreme chemistry added to this is the possibility that Neptune is of exotic materials. Now, laboratory simulation mentioned growing evidence that the planet materials and liquids are hydrogen atoms, creating a kind of electrified soup. This phase of matter could not only explain some of heat generation and electromagnetic anomalies, could also be a key component of its internal structure. Under extreme pressure and the surface in currents much more complex for Jupiter. Tyson also saw the planet's extreme winds 2,100 km/h from a new perspective. Traditionally, the differences in rotational dynamics suggests from within the planet systems from stabilities. These transitions between materials under pressure. It would be the first known example of a planet by its own internal dynamics. This revelation also has has important implications for exoplanet research. Exoplanets similar to Neptune, Neptunes, are one of the most commonly detected types of planets outside our solar system. If Neptune is so different from what these thousands of worlds could be just as different, the classification and modeling of these planets may need to be completely revised. Tyson emphasized that our assumptions about their composition and evolution are wrong. Finally, an even more theoretical but intriguing possibility in an intermediate category between planets and brown dwarfs. So Neptune is far from having the mass necessary for fusion. Its unusual internal heat and dynamic energy that requires a new categorization, redefinition of Neptune, but also of how we understand it in general. It suggests that there is a much greater diversity of planetary types than we previously considered, not just in size or atmosphere, but in internal architecture. Tyson described Neptune as a system in equilibrium and constantly changing self-balancing forces, driven not by the slow decay of energy, but by its erratic processes within. This revelation also highlights the fundamental role of the most advanced observational tools. Without the James Webb Space Telescope and ground these patterns as cloud cover. Tyson was clear on this point. Our ability to truly understand the universe depends on the instruments we build to observe it. Our view of the cosmos, the possibility of discovering more worlds increases, complex, misunderstood, and ready to rewrite everything we think we know. Of this revelation will surely spark debates about the limits of our current scientific models. If one of our own planets can surprise us so radically, what else awaits us beyond? Neptune, once considered is now as possibly the most exotic member of our solar system. And with that, we are reminded of how little we really understand about the universe. This announcement is not just about Neptune, it's about art of knowledge, the humility of science, and the ability of discovery. If you like video, don't forget to subscribe to our channel for more updates.